Welcome to Mr. Glance's Flipped Classroom, where math knowledge makes things easier. Today, we'll be able to solve rate problems using double number line models. We're focused on the Common Core state standards associated with ratios and proportional relationships, specifically the 7th grade standard 7 RPA1, in which we'll compute unit rates associated with ratios of fractions, including ratios of lengths, areas, and other quantities measured in like or different units, as well as 7 RPA3, in which we'll use proportional relationships to solve multi-step ratio and percent problems. Let's take a look at one of those problems. Here we have a train which travels 300 miles in 4 hours. The rate is 300 miles in 4 hours. At this rate, how far will it be able to travel in 12 hours? We could solve this problem in one of two ways. We could figure out what the unit rate is. The unit rate is when you have a rate that's associated with one unit. In this case, it would be miles per hour, miles traveled in 1 hour. Once we figure out that distance per hour, we could multiply by 12 to find out how far it would travel in 12 hours. Or we could look at these 4-hour units and see how many of those would fit into 12 hours, how many miles in 4 hours, and how many 4-hour units we have in 12 hours. Let's first look at unit rates. The train is traveling 300 miles in 4 hours. At this rate, how far will the train travel after 1 hour? Well, in 4 hours, it's going to travel 300 miles. Half of that amount of time, it should travel half that distance. So half of 4 is 2. Half of 300 is 150. Half of 2 hours is 1 hour, which is what we were looking for our unit rate. How far will it travel per hour? Well, half of 2 is 1. Half of 150 is 75. So the train is traveling 75 miles per hour, 75 miles every hour. If we wanted to figure out how far it would travel in 12 hours, we could just multiply that by 12. So 75 by 12 would tell us how far it would travel in 12 hours. Or we could look at this as 4-hour units. Here's our unit rate again. That would be 1 hour and 2 hours, 3 hours, and 4 hours. 4 hours is 300 miles. 1 hour we calculated as 75 miles, and remember 2 hours was 150. But here we're looking at 4-hour increments. So if every 4 hours the train will travel 300 miles, so after 8 hours the train should travel 600 miles. Double the amount of time should be double the amount of miles, double the distance. Every 4 hours is another 300 miles, so after 12 hours the train should travel 900 miles. We just add another 300 miles to the previous 4-hour increment. What we're really doing is finding an equivalent ratio, 300 miles in 4 hours. To find how far the train is traveling in 12 hours, we could find an equivalent ratio by multiplying that ratio by the big one. As you remember, we learned previously that every fraction is a division problem. And if you have a numerator and a denominator that are the same, 3 divided by 3 is merely going to be 1. 4 over 4 is also 1. 2 over 2 would be 1. Why are we multiplying by 3 over 3? Because in this case, we wanted to find out how far the train would travel in 12 hours. We would have to multiply 4 hours by 3 to get a denominator of 12 hours. If we multiply the numerator by the same number, all we're doing is finding an equivalent ratio. This ratio of 300 to 4 is the same ratio as 900 to 12. 300 times 3 is 900. 4 times 3 is 12. We know that's an equivalent ratio. If you understood what we dealt with until now, then let's look at this new problem. Michael was able to fit 95 cookies on 5 trays. How many cookies will he be able to fit on 20 trays? Here's your double number line. You know 95 cookies on 5 trays. And we want to calculate how many cookies will fit on 20 trays. Remember, each 5-tray increment should add another 95 cookies. Looking at our double number line, you should be able to calculate how many cookies would fit on 20 trays. There's our ratio, 95 cookies for every 5 trays. You want to multiply that by the big one. A certain number multiplied by the denominator to get a denominator of 20. The big one says that you're going to be multiplying the same number on the numerator as you did on the denominator, so that you're multiplying by 1, and this ratio is going to be the same proportional relationship. Take a moment, solve the problem. If your teacher says it's right, and you've learned how to solve rate problems using a double number line.